but then they won't be long. So let's see. Let everyone know they are being recorded and transcribed. Okay, so let me ask a question. What is ukupapa in English? Ukupapa. What is that in English? Can someone
to appease?
Forward,
Being too forward, I think. Being too forward.
Yes, be forward.
Being too forward.
Okay, it means me and your lecturer and the students for Math 1510 were paparing because it looks like the session we are covering now, we have covered because we talked too much and we were paparing and we were enjoying the module. So I don't know whether it will be revision or it will be a new section, but let's continue and see. So it means if you were revising your work, this will be you just understanding because you papared and you enjoyed the module and you understood your work. So let's go and see. So we have trigonometric functions of angles. And then we have trigonometric functions of angles, evaluating trigonometric functions at any angle, trigonometric identities, areas of a triangle. The first part is trigonometric functions of angles. Now let's go back. They say, look at let POQ be a right triangle with an acute angle as shown in figure A. Place theta in a standard position as shown in figure B. Do you remember what a standard position is, right? When we say an angle is in standard position, guys. Hello?
Yes, ma'am, we're here.
Do you remember when angle is standard position? Guys, this is just like revision. When I saw it, I'm like, ha.
Yes, ma'am.
You remember what
standard position starting from OX, if I'm not mistaken, or if I still remember properly.
Yeah, from the 10 point.
Yes. Remember an angle has a vertex, has the initial side and the terminal side. We call this R1, we call this R2. If you take this and always start here and move around like this or like that, then you are in a standard position.
Okay, ma'am.
Yes. So if you don't remember, go back. Make sure when you're writing these things that we talked about before the recordings, go back to your work as well. Now they say then P is equals to X and Y. So is a point on the terminal side of theta. Terminal side of theta. We know what terminal side of theta is. In triangle POQ, the opposite side has length Y. Do you see that? So they say this is the theta, this is the opposite. Opposite to theta has the side Y. And then they say the adjacent adjacent side has the length X. Now we call this X. Using the Pythagorean theorem, we see that the hypotenuse has the length R squared, meaning this one here is R squared. Are we all together?
Yes, ma'am.
Right? So sine theta is then Y over R, which is opposite over hypotenuse. Cos theta is X over R, which is adjacent over hypotenuse. And tan theta is Y over X. Yeah. Now they say that the other trigonometric ratios can be found in the same way. These observations allows us to extend the trigonometric ratios to any angle. Right? Now, we define the trigonometric function of an angle as follows. Now look at this. Do you see that the angle starts from here, from this point to that point, guys? Hello?
Yes, ma'am.
But look at where the 90 degrees angle is formed. It's here. Do you see that? So meaning that the theta, when you are here, the theta is now here. Let's call it theta bar. They don't call it, let's not call it theta. Let's call it theta bar. It means you'll be working with theta bar to solve these ones. Are we all together? Yes or no?
Yes.
Okay. Now they're saying that the definition of the trigonometric functions, let theta be an angle in a standard position, let P be a terminal point with X and Y, or be a terminal point side. If R is equals to the square root of X squared plus Y squared is the distance from the origin to the terminal point, meaning from here to that point P, then sine theta is equals to y over r, cos theta is equals to x over r, tan theta is equals to y over r. And then you know cosec theta will be r over y, sec theta will be r over x, and cot theta will be x over y. Now, take into this consideration the restriction where y is not equals to 0, x is not equals to 0, y is not equals to 0, and this one is also not equals to 0. Are we all together? Yes or no?
Yes.
Yes.
Yes, ma'am.
The angle for which the trigonometric functions may be undefined are the angles for which either x or y coordinates of the points on the terminal sides of the angle is 0. So meaning that the only time these angles will be undefined, it means this one will be undefined when x is equals to 0. This one will be undefined when y is equals to 0. This one will be undefined when what? When x is equals to 0. And this one will be undefined when y is equals to 0. Are we together?
Yes, ma'am.
Yes, ma'am.
Good.
We're together,
So
ma'am.
now they are saying that these are quadrantal angles. Okay, let's repeat the statement. The angles for which the trigonometric functions will be undefined, are called quadrantal angles. Can someone tell me what are quadrantal angles? Hmm? Can someone try what quadrantal? And remember, there's still that reward for December, eh? What are quadrantal triangles? What do you
I
think
think
they are?
they are angles in a.
Hmm?
Okay. I think they are angles in a standard position. We whose terminal sides lies on an axis.
Well done.
Hmm.
It's even written here. So what are those angles? Give me those angles.
0 and
They
then
are
90.
0,
90
90
degrees.
degrees. 1
90 degrees.
What is 90 degrees? Remember, now we're dealing with radians.
Pi over 2.
Thank you.
Over 2.
Pi
Thank you.
and 3 pi over 2.
Pi over 2.
also pi.
Reason
Pi.
being, these angles, one of them is x and one of them is y. Whether it's a unit circle or not, one of them will be, for example, here x will be a number and y will be 0. Here y will be a number and x will be 0. Here x will be a number and y will be 0. And here y will be a number and x will be 0. So that's why they say for the quadrantal angles, some of these trigonometric ratios will be undefined. Does it make sense now?
Yes, ma'am.
Yes.
So in a crucial fact that the values of a trigonometric function do not depend on the choice of P. So they're saying the values of a trigonometric function like sine theta is always x over y. That's what they are saying. right? So they're saying that it is a crucial fact that the values of a trigonometric function do not depend on the choices of the point xy. This is because if you choose a new point, let's say this triangle here, you see there's a first triangle there, right angle triangle, and then there's a second one where the point is prime. So they say this is because if P prime prime is any other point on the terminal side, as in figure 3, then the triangle POQ, meaning this small triangle in here, the one I'm highlighting, and the P dash OQ, which is the big triangle, they are similar. And by looking at them, which property do you the ones that says which property applies to these two triangles? Which similar property applies to these two triangles? Guys?
Ma'am, can you at least elaborate more further when you're saying property, ma'am?
Remember when they say two triangles are similar, what do they mean? You
Okay,
forgot.
from this triangle, for this triangle, we've got OPQ1. They share the same angle. They share theta.
Well done. They share theta and
the lines
90
are parallel to the lines are parallel, which is Q and Q bar are parallel to each other.
Okay, let's not look at that. So this, they share 90 degrees, 90 degrees. And then what is this angle here? What is this angle here? Do you agree this angle is an angle where you add this one and subtract from 180? Let's call it beta.
Yes, ma'am.
Yes.
And you see this angle will also be beta as well.
Yes, ma'am.
Do you see that? So this
Yes,
is
Yes,
angle.
ma'am.
So the angles and the angles and the angles are the same. Hence the statement that says it is a crucial fact that the values of a trigonometric ratio function do not depend on the choice of the point px. This is because this point and this point are what? This is because this triangle and this triangle are similar. Are we all together there?
Yes, ma'am.
Okay. So now they say evaluating trigonometric functions at any angles. Now, from the definition, we see that the values of the trigonometric functions are all positive if the angles theta have its terminal side in quadrant 1. This is because x and y are positive in this quadrant. Of course, r is always positive. Since it is simply the distance from the origin to the point P, which has x and y. If the terminal side of theta is in the second quadrant, however, then x is negative and y is positive. Thus, in the second quadrant, the function sign and whatever are positive, and all other trigonometric functions are negative. All these statements, we covered them. That's why I said we papered, because we covered work that are in here in the previous sections as well. Can someone tell me what are they talking about? What diagram are they talking about here?
On which paragraph, ma'am?
All of these paragraphs. What diagram are they talking about? They are saying if your angle is in the first quadrant, the trigonometric ratios, all of them are positive. If your angle is in the second quadrant,
they're talking about the Anastasia graph.
Yes.
Yeah, but check it.
Of
Yes.
course. What do you what other word can you call it?
The cast, what is it? What is it called?
The cast diagram.
Yeah, cast diagram.
There we go. They're talking about the Anastasia diagram or the cast diagram. Thank you very much. Oh, there we go.
I wanted to write Anastasia graph in the assignment, then I was like, maybe you won't mark my.
And it's not me who's marking your assignment.
They were going to be offended.
I know. Some people are like, why would she give? Of course, my name fits. It's not their problem. It's not my problem. Their names don't fit in the cast diagram. So, as we said, the Anastasia diagram or the cast diagram, if you want to call it, some people will call it something else. It says that in the first quadrant, all of them are positive. Do you see that? In the second quadrant, only sine is positive, and cosec, because we know that sine is what is one, or cosec is one of a sine, and all of them are negative. In the third quadrant, only tan and cot are positive because there's a relationship between tan and cot, and all of them are negative. And then in the fourth quadrant, we know cos is positive and all of them are negative. And sec will also be positive because there's a relationship between cos and sec. There we go. Look at them. They say all students take calculus. Why would I stop from using my name? Huh? Look at this. They say all students take calculus. And you say the cast diagram or the Anastasia diagram. Do you see that we're looking at work that we have covered already, guys?
Yes.
So on this slide, do you understand everything here? Can I move on?
Yes, ma'am.
Thank you. Now, find cos 135 degrees and tan 390 degrees. Those who are even here last week, they should just look at it. And those who have been attending and looking at the recording, they should look at it and say, yeah, this is the value. Come on, guys. Don't disappoint me. Guys, what is cos 135 degrees? And we're not using calculators, remember? Hello?
Yes, ma'am.
What is cos 135 degrees?
You want the terminal?
No, you know in the calculator when you say cos 135 degrees, it gives you an answer.
Okay, so it means I was going to use the...
But I don't want to use the calculator. So that's why I'm saying, what is cos 135 degrees?
May I try?
Yes.
Okay.
All right. Cos of like 135 is the same as cos into 180 minus 45. Then the answer will be minus root 2 over 2 because of it's on the cos on the second is negative. Therefore, my answer will be minus root 2 over 2.
Well done. Brenda, were you trying to say the same thing?
Yes, ma'am.
Well done. You see, you guys covered this work already. We're just going through. Let's go through. So we need to go back and say, we remember our unit second. We remember our unit second. Did someone not understand? Okay, now they're putting in degrees. So let's work in degrees. So we have 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Remember, we know that here we have a 45. If we have here like this, okay, let me use a different color. I always forget I have different colors. The choice of using a laptop. So remember, when you draw here, you have a 45. When you cut into half, you have a 45 on top, 45 at the bottom. When you cut into another half, you have a 45 there, 45 there. So we know that from here to there, that's 45 degrees, isn't it? So let's put it up here. So it's not pi over 4. It's 45 degrees, isn't it? Right?
Yes, ma'am.
Now, we know if now we are moving 45 to get 135. What's this? To get 135, we can either use a reference. Do you remember that referencing thing? Reference number or reference angle. Do you remember that one? Guys?
Yes.
So meaning that we go
Yes,
and
ma'am.
count where is 135 by using the reference number, right? Or reference angle in this case. And now I'm papering because I think that's the next session. Let's call it reference number. We know 45 is here. Plus 45 we go to 90. Plus 45 we go to 135. So meaning that our angle is from here to there. That's 135. Because we are using a reference angle, we know we're going to say from here to there. So then it means that this is the same as what? This is the same as 180 degrees. We're looking for the reference angle. Let's call it theta bar minus 135 degrees. So this is equals to what? This is equals to 45 degrees. That's our reference angle. And we know 45 degrees. What are the points for 45 degrees, guys? X and Y of 45 is what?
Square root of 2 over 2 and square root of
2 over 2.
Thank you. But where is 135? Before that, we know that our terminal point,
135 in second quadrant.
thank you. Our terminal point has the same values as the reference number, but with different signs. Now, because of the cost or the anesthesia, I'm going to call it the anesthesia diagram. Because of the anesthesia diagram, we know that 135 is here. 135 is here. Is in what? Is in second diagram. And because we are looking at cos of 40 or 135, then it means that cos of 135 is the same as cos of 45. But because it's in the second quadrant, cos is negative.
Sign changes.
Thank you. And remember the relationship here. We said this here is the same as cos of t. Let's call it cos of theta because we are dealing with theta now. Cos of theta and sine of theta. Do you remember that relationship between the terminal point and the unit circle? Because we see these values are what's this? Especially if you are dealing with special angles, your pi over 2, I mean your 90 degrees, your 45, your 60, and your 30, you can always refer to these points of the unit circle. Are you all together?
Yes, ma'am.
So it means now root 2 over 2 is this one. So it becomes negative root 2 over 2. Are we happy?
Wait,
Yes,
ma'am,
ma'am.
can I ask? So you just want the x value and not the y? Since
I just
you
want
don't
the
know.
no, because
Yeah, because
remember,
it's saying find cos.
yes, find
Cos
cos.
is A.
Oh, it's x. Oh, I get you. I get you.
Find cos. Are we all together now?
Yes, ma'am.
Yeah, together, ma'am.
Thank you. Let's see if we got the right answer. The right answer. The pen is no longer writing, guys. I don't know what's going on. Let me see if I can. Hey, discharge. Okay, escape. Discharge. And yes, our answer is correct. Can you try tan 360? What is tan 360, guys? While I'm trying to figure out. Oh, there it is. I don't know what was going on. Let's try tan. And well
the
done to
angle-
us. Yes, tan 360.
The angle, 360, not 290.
I mean,
0.
390, sorry, man. Tan 390. Let's try tan 390.
Tan 390, the reference angle for tan 390 is 30 degrees because you rotate once, one
Continue.
revolution,
Mm.
and then you go again for 30 degrees. So tan 390 is the reference angle is tan 30, I think, which is because 10 is sine theta over cos theta, if I'm right, ma'am.
Okay.
Yes,
Continue.
and then the point for 30 degrees is for the x-axis is square root of 3 divide by 2 and then half. So you'll divide square root of 3 over 2 and then you over half, and then you multiply like that.
What is the answer? I want you to get to the answer. You can't drive me to the mall and leave me by the robots. You need to take me to the mall. Yes. What is the answer then?
Okay, let me try to calculate, because I don't have my calculator here with me. So I'm going to try and calculate. It's square root of 3.
You don't need a calculator, my dad.
We're not talking about calculators. That's why I want you to drive me straight to the mall.
Yeah,
You can't
it's
push
square
me
root of
by a river.
I
Come
got
on.
the square root of 3.
Guys, I'm proud of you guys, really. I'm proud of you. Like, you guys are combining all the sections. You're talking about the revolutions in the roundings and the terminal points, and you're combining all these sections. It's making me so exciting. So excited, not exciting. So excited. And when I'm excited, I enjoy maths. Okay? Let's see. She says the answer is square root of 3. She said that. Huh? She said, okay, what did she say? Let me remember correctly what she said. She said that I go and write. Now, here, do you see that we're still dealing with a unit circle, because 390 is also like form of like a special angle, nyana. Guys?
Yes, ma'am.
Thank you. So she says we go this one and we do this one, 270 and 360 degrees. So 0 degrees has to be on top here. She says that I start from here. Right? From here. I move around and it says 3. When I get here, it says 360. But I know 360 plus 30 degrees, it gives me 390. It means that I end here. Do you see that? So this is 30 degrees. And because of what I have learned, 30 degrees, if I choose a terminal point here, 30 degrees of that terminal point will be what? Root of 3 over 2 and 1 over 2. Do you remember that one, isn't it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
If you don't remember it, you can also use your triangles that we have learned. 45 degrees, 45 degrees, 1 root of 2. And then we have that one. The 60 degrees and the 30 degrees. And we have 1, 2, root 3. Right? And then we know that from here, the radius is what? From here, the radius is 2. Because we know this, the radius is 2. Oh, sorry, we're looking at 30, right? So the radius is 2. So we know that this will be 2. I just want to show the relationship. So this will be 2. What is the pen doing now? I don't know what's wrong with the pen today. Is it the bitch? Hey, pen. What have we done to you today? Let's do this. Okay, thank you. Let's go back. Okay, so we know that if we say, for example, sine of, because we're looking at 30, sine 30 degrees. We know sine 30 degrees is opposite of hypotenuse, so that's 1/2. Cos of 30 degrees, we know what's this? That's adjacent over hypotenuse, which is square root of 2/2, square root of 3/2. Do you see these points also have a relationship with those points? So this is what? Sine of 30 degrees, so this is cos of 30 degrees and sine of 30 degrees. Do you see the relationship, isn't it, guys?
Yes.
Yes.
So meaning that when you go down like this will be what? This will be your opposite, and your opposite is represented by y. Remember the new expression, sine is equals to y/r. So this is y, and y in this case is what? Y is 1. And then x in this case is what? X is the square root of 2. Because here, this is cos. We know cos of 30 degrees is equals to x over r. And in this case, our x is √3/2. I'm just showing the relationship there before going to what she was talking about. Are we all together there?
Yes, ma'am.
Yes.
Yes,
Thank you.
ma'am.
So it means that, let's go back to what she was saying.
Oh.
It means she's saying that now, because of tan of 30 degrees is equals to sine of 30 degrees over cos of 30 degrees, then you can say sine of 30 degrees, we know it's what? It's 1/2, so that's 1/2. Divided by
Root 3/2.
okay, 2. So this is equals to √3. Do you see that?
No,
No, ma'am, 1/√3.
I made a mistake. It's root
Because it was 1/2 times 2/3, so it becomes 1/√3.
Now
I
she
made a
only confesses now that she made a mistake.
No, ma'am, I like because
So that's 1/3.
Yeah, then we rationalize
Then it becomes, after rationalizing, we have √3 over what?
over 3.
three.
But three.
Okay, by rationalizing, we're meaning that we're just taking the denominator because it has a third, it's a third, then we say √3 over √3. We know that √3 times √3, so this is equals to this times this, that's √3, and no, √3 times √3 is just over 3. So it's √3 over √3. Do you see that, guys?
Yes, ma'am.
Yes.
Thank you. So now, well done. Let's see if we are right. You see? Ah, la la. Are you guys? I'm telling you, I can bet on you. Everything she spoke about in one sentence. When we write about the signs, let's look at the signs. When we write it's positive √3/3.
Yes.
Please fix why.
Yes.
Why positive √3/3 and not negative? Because
it finished a complete revolution and it's in the first quadrant.
well done.
First part, they're all positive.
Thank you. Alala. Ow, you see, when I say we are paparing, look at this. Now they're calling the reference angle. Before we're calling it a reference what? Number. Because we're dealing with a T. Remember, we had a T, bar, calling it reference number. Now we are calling it theta, bar, a reference angle. Let theta be an angle in a standard position. The reference angle theta bar associated with theta is the acute angle formed by the terminal side of theta and the x-axis. Do we know what that statement means? Guys? We know that's what that statement means, isn't it? Hello?
Yes, ma'am.
So it means we can continue then.
Yes, ma'am.
There we go. It's not something new, ne? Eh?
How did we skip there?
No, ma'am, it's not, and it's not something new. They just replacing T reference of T with just theta.
Do you see that? Amen. Amen, sister. Amen. There we go. So they say figure 6 shows that to find a reference angle, theta bar, it's usually it's useful to know the quadrant in which the terminal side of the angle lies. As she said, they just replaced T bar with theta bar. Are we all together, guys, or is there someone confused? If you know how to find the reference number, now you know how to find the reference angle. Okay, there's something I want to remind you, ne? Guys, there's something I want to remind you, especially with the fourth one. Remember, we said that if you're going to move like this fourth one, ne? Then it will be 2 pi minus that angle, isn't it? That you have moved with.
Yes,
Right?
Yes, ma'am.
But if you
Yes,
move from here and you move like this, we said the movement, that angle is the reference angle. Do you remember that one? I'm just reminding you so that you don't forget.
Yes, ma'am.
Okay. Thank you. There we go. Find the reference angle. Let's talk about the first one. I already know the answer. You're supposed to know the answer because you did assignment 4. This is assignment 4, guys. Just in, in a different case. What is A? Find the reference angle for A. Can someone come in?
Yes, ma'am.
So
Oh no, pi over
Pi over 3.
over 3.
I told you that the work we're covering today, it's something you know. And because we know that pi over 3 is also like a special triangle, special angle. So it means that because so this is 0, pi over 2, pi, and then 3 pi over 2 and 2 pi. So we know that, okay, fine. The reference angle, okay, let's say, I don't know why am I saying pi over 3 there. So we know that from here to here is pi over 3. Okay, sorry, this is the middle. This is pi over what? The middle is pi over what, guys? Remind me.
Pi over 4, 45 degrees.
Thank you. And this one will be pi over?
Pi over 6.
Pi over 6.
And then this one will be pi over?
3.
Pi over 3.
Thank you. So remember, I said when you come here, you pretend as if this is a 0. So it means that this one will be pi over?
Pi.
From here, it's 0, guys.
Okay.
So this one will be pi over?
Pi over
6.
6.
This one will be pi over 4. And this is also pi over 3. But it's not really pi over 4, pi over 3, and whatsoever. So I'll remove that. I just want to remind you that from here, so here as well, 1, 2, 3. It's like you're starting from 0 again, and you're saying 30, 45, 60. And here it's 30, 45, 60. Now they're looking at 5 pi over 6 over 3. We know pi, over 3, we know it's a 60 degrees, isn't it?
Yes.
So meaning that from here to there, that's pi over what? Pi over 3. How many pi's over 3 are we looking for?
5.
5.
How many pi's over 3 are we looking for?
5.
5.
5 or
5.
2.
So this one is the first one. Where am I going to stand here for the second pi over 3? 2 pi over 3, where am I going to stand?
You're going to...
Okay, let me label them. 1, 2, 3. 1, 2, 3. 4.
1. You're standing at
4. 1, 2, 3, 4. So am I going to stand at what?
1.
1.
Do you all agree? So this
Yes,
is 2 pi over 3. Reason being, from here at pi over 3 to here, it's 30 degrees. And you know 30 degrees plus 60 is 90. And 30 degrees plus another 30, you stand here. So this is the second pi over 3. Where am I going to stand on the third pi over 3?
On pi 4. Number 4.
So this is
On
3 pi
on number
over
3.
3. Why are you saying number 3?
Wait. How many are we adding? 30 must. Where?
What is pi over 3? Is it 30?
Oh, yeah, 3 over 3. Sorry.
Okay.
Oh, sorry,
And then
we are 2 pi. We add a pi, then it becomes 3 over. Yeah, sorry.
yes. So where do we stand next position now? Because we're looking for 5 pi over 3 and not 3 pi over 3. So where do we stand in the next position?
So we add the pi, and we have 4 pi over 3 is gonna be
Number 3.
Well done.
number 3 at the bottom.
So we go move number 3. So that's 4 pi over 3. Where is the last pi over 3?
Number
Number
1.
1.
Well done. I want you for it to be in your head. So that's 5 pi over 3. So for us to get a reference number, we'll say what? They call it a what? A reference angle. We'll say what? Okay, so it means we are in this position. We are here. So what are we going to say for us to get a reference angle?
2 pi.
So we know 5 pi over 3 is from here, and it move around like this. So that's the theta. Now the reference angle is this one over here. So we say what? You said what? 2 pi minus
Yes, ma'am.
pi over 3, in which we get this pi over 3. This one over here. Are we all together, guys?
Yes, ma'am.
Thank you.
So, ma'am,
If what was the question?
oh, sorry, I was muted. I'm saying, let's say I'm not using the diagram. I just say like 5 pi over 3. Then I subtract pi. Then I know I'm looking for the distance, and the distance cannot be negative. So when I subtract pi from that, I'm getting minus pi over 3. Then since I'm looking for the distance, I'll discard the negative. Then I'm left with pi over 3. Will I be wrong?
Yeah. No, sorry. You are right.
Okay.
So you're saying that maybe yeah, especially if you are in the third quadrant, you can't say pi minus whatever in the third quadrant. You'll say whatever in the third quadrant minus pi.
Okay, ma'am.
Yes. Because you're looking for the reference angle, so it will be positive. Okay. Can someone give me the reference angle here?
That
also 30 degrees.
It's pi over 3. That's one. Hey, ma'am.
Pi
B.
over
No, with B, you
Yes,
see.
ma'am. Yes, it is. We subtract multiples of 360. So 360. Yes, it is 30.
30 degrees.
Yes, ma'am.
Let's see.
Yeah, because we 870 minus 720. That give us 150. Then we subtract it from pi.
Okay. Let's
And we
see.
have 30 as our reference.
I love diagrams. That's the thing. You see me, diagrams, I love them. I love them. I love diagrams. I love diagrams. I'm glad that you guys can see that this work is work we covered and we are able to apply it. Okay. So now let's see. We're saying that we start from 0, we move around, and we get 360, right?
That's one. We move again.
Okay, guys, when there's a voice behind, I can't focus. 270 degrees.
Tato, mute your mic. Tato, monon.
Brenda, I think it's you. Brenda?
It's Tato, ma'am.
Tato. You are disturbing me.
Sorry.
Because when there's a voice, I'm so disturbed. I get distracted very easily. Thank you. Yeah, I almost removed you in the... So the first 360, right?
Yes, ma'am.
And then
Yes, ma'am.
another 360, we have to move again. Where do we go? It becomes what?
720.
720. But because we have 870, do you see that we're not going to move another 360? So from here, let's calculate 870 degrees minus 720 degrees. What do we remain with?
150.
150
ma'am.
Thank you. So it means 150 degrees is here. It's here. So from here to here. It means our 150 degrees is here. Do we agree that our 150 degrees is there?
Yes, ma'am.
So our reference
Yes, ma'am.
is this one. So 150. So theta pi is equals to 180 degrees minus 150 degrees. So this will be equals to what? 30 degrees. Well done. I'm proud of you guys. Well done. Okay, let's see if we were right. We said our first answer is pi over 3, and yeah, yes. Our second answer is 30 degrees. Yes, well done. Now we come to this. You won't tell me you don't remember this as well. Do you remember this, guys? Evaluating the trigonometric function.
Yeah, we remember, ma'am.
I remember it, ma'am. Yeah.
So evaluating the trigonometric functions for any angles. To find the value of a trigonometric function for any angle theta, we carry out the following step. First, find the reference angle theta bar associated with angle theta. Determine the sign of the trigonometric function of theta by noting the quadrant in which theta lies. The value of the trigonometric function theta is the same except possible for the sign as the value of the trigonometric function of theta bar, meaning theta bar and theta have the same values of x and y, but they do not have the same sign. That's what they're saying. Because theta bar is a reference angle. Are we together?
Yes, ma'am.
Yes, ma'am.
Use your brains. Give me the answer now. Sine 16 pi over 3. What do you think? A. The answer is what? Guys?
Pi over 3.
Sine 16 pi over 3. So the answer is what? I want the answer. Because here you're using your mind. Isn't that we learned this thing?
3 over 2.
It's
So you
what?
want the terminals?
Yes, I want the answer. Sign like the way you get in your calculator.
Negative root 3 over 2.
Negative root 3 over 2.
Yes, ma'am.
Okay. And then, okay, sorry guys, I need to look at something here.
Yes, I agree.
And then B, sec negative pi over 4. The answer is sec, not sine. Sec negative pi over 4, please.
Root 2 over 2, ma'am. Is what I got.
You got from doing what? Not a calculator, right?
No, ma'am. Not a calculator.
I disagree with you here.
Okay.
Why? Think again. This is sec.
Okay. Yes, ma'am.
So it's supposed to be what?
It's it's
1 over cos.
1 over cos.
So then it has to be what?
It has to be
They have to be root 2. I think.
okay. Okay, I get it. I understand now.
So it will be what? The answer?
It will be root 2 over 1.
Root 2 over? It will be what?
Ma'am, would the answer be just root 2?
No, you tell me. It will be
Oh,
what? The
okay.
answer? It can't be root 2 over 2. So it will be what? As
Just
you
root
said.
2. Okay, it's 1.
I think maybe it will be 2 root 2 over.
Do you see that, guys?
Yes, ma'am.
Ma'am.
Which is the same as what? Yes? Someone is
root
saying,
2.
ma'am?
Ma'am,
Yes?
I'm a bit confused here. Oh, I don't know if it's maybe I've joined your class late. Like, how do we get like these answers here?
Can someone explain how do we get these answers here?
We use the reference number. Then you find which quadrant do they fall in.
Okay. Before we advise that, did you understand your previous videos? Because this is literally previous work.
Oh, now I see. Now I see, ma'am.
Okay. So someone might ask that, okay, if there's two, why is it root 2? It's because when you rationalize, you say times root 2 over root 2, and then 2 times root 2. So this will be 2 times root 2 over root 2 times root 2. It's 2. So this 2 cancels that 2. So then you remain with root 2. Are we all together?
Yes, ma'am.
Yeah.
So let's see if
Yes.
we are right. I'll be very quickly. Yeah? I know that I have 16 pi over what? Yeah? And we did have something that says sine of pi minus 2 pi. Do you remember that one? Ooh, go Sam. Minus 2 pi, the same as sine pi. Do you remember that one? Guys, that relationship, or sine of pi plus 2 pi.
Yes, ma'am. Yes.
Is the same as sine pi.
And pi. Yes, ma'am.
So now we go to that relationship and say, okay, fine. Before we start with, let's find the reference angle. That's what they're saying. We have 16 pi. So it means 16 pi. Before we find 16 pi, we need to reduce this 16 pi over 3. So we know that 16 pi to reduce it so that it can help us to find the reference angle. We're told to minus by 2 pi. Then we get what? When we minus 2 by 2 pi, what do we get, guys? I think we get 10 pi over 3. Over 3.
Over 3. Yes.
Which is still big, right? So it means that we can go again and say 10 pi over 3 minus 2 pi. We get what?
4 pi over 3.
4 pi over 3. So this 4 pi over 3, we can then use it now because it's simpler. Do you see that? It's simpler to go in on the, what's this? On the Cartesian plane to get 4 pi over 3. So we're going to go on the Cartesian plane to get 4 pi over 3 and see where it's located. So it's 4 pi over 3. So we go and say, okay, fine. We know this is 0, this is 90 degrees, this is 180 degrees. We're not working with degrees, so we need to be careful. So this is then 0 pi over 2, pi, 3 pi over 2, and then 2 pi, right? So we know that, okay, let me draw the lines. Just a reminder of the work that we have covered. We know that if I draw a line that cuts like here, that's a pi over 4. And that's more of a pi over 4, but I won't write pi over 4 as well. We know that when you draw another line that cuts, that's also another pi over 4. And then when you draw a line that cuts like this, we know that this is pi over 6. And this here is pi over 3. So that's a pi over 3. Okay, here we need to draw another pi over 3 and another pi over 6, like that. So let's label them because we're looking at 4 pi over 3. Ne? So we have 1, 2, 3, 4, 5, 6, 7, 8, 7, 8, 9, 10, 11, 12. Okay, so our first pi over 3, do we agree it starts from here, it comes here? That's our pi over 3.
Yes, ma'am.
Where's our second pi over 3, guys?
At number 2.
Number 2.
Thank you, well done. It's here at number 2 because pi over 3, we know it's 60 degrees. And we know from here, add by 30, you get to 90, add by 30, you get here. So that's
Number 2.
pi over 3. Whoever doesn't understand what I'm doing, guys, the previous videos explain properly. I explained step by step. Because we're looking at 4 pi over 3, guys. We are not done. Where do I go next?
Number 4, ma'am.
Do you agree? Number 4.
Number 5.
Oh,
Well done.
5. Okay, I
Yes.
didn't see the red line. Okay. Sorry.
Yes, because this, remember, this red line is the same as
Yes.
0, so it means you only
Yes,
have moved 80 degrees.
Yes,
So
ma'am.
if you move another 60 degrees, you get to number 5. So that's how, what? That's 3 pi over, that's 3 pi over 4. And we're looking at pi over 4. Where's another one?
I would say number 8.
Number 8.
Number 8, ma'am. Number 8.
So that's 4 pi over. So meaning we are in the what quadrant?
In the third quadrant, ma'am.
Third quadrant.
To discharge. And then I want to go back. So it means for this one, because we are in the third quadrant. So let's go and draw. So we are here in the third quadrant. In the third quadrant. So this is 4 pi over 3. Are we all together?
Yeah, together, ma'am.
Yes, ma'am.
Now, what is the reference angle then? What is the reference angle? Guys?
For which one, ma'am?
For this one, we are in the third quadrant. With our 4 pi over 3, we are in the third quadrant. What is our reference? And Brenda, you should know this because you asked the question.
So we so we subtract from pi.
Well done. But how do we say it? So our reference angle will be what?
Our reference angle will be pi minus
Remember,
4 pi over
4
3
pi over 3 minus pi.
thank you.
minus pi.
Remember, it's what you just asked. If it's in the fourth quadrant, then you say
from what quadrant we are minus pi.
thank you. So now this becomes what?
Pi over 3.
Pi over 3.
So meaning that sine of 16 pi over 3 is the same as sine of what? Of 4 pi over 3, but is also the same as the sine of pi over 3. But because pi over 3 is a reference angle, we need to go and check what is the sine of pi over 3. Where is the, according to the Anastasia diagram, why is the pen not writing now? Okay. Guys, today I don't know why the pen is crazy. Let's go to Word, let's fix it. I'm not sure if it's the batteries or what.
It had that you were saying you were cruising today. You were like, no one to slow you down.
I'm telling you, and I'm like, we need to be cruising. Okay, let me see if I can write with my pencil then. It means that the batteries are low. Where's my pencil case? Pencil case. Or maybe if I bite the battery. You know us, we bite batteries and then we think it'll work. Should I bite the battery? Hey, I'm telling you, that's a skill. You bite the battery.
But does that really make some changes in the battery, ma'am?
I don't know, but I've seen working. So our reference angle, this part here, is pi over 3. But we know according to the Anastasia, what am I saying? Look at now, I don't even know my name. Shear diagram, right? We know that in the third quadrant, only 10 and quarter positive. Sign is what? Is negative. So we put a negative. There we go. So meaning that, let's do this. I don't know what's going on now. Sign is negative, meaning that the answer here will be, what is sine pi over 2? Let's start there. What is sine pi over 2? Eh? Guys, what is sine pi? Sine pi over 3.
It's half. Oh, no, square root of 3 over 2.
It's root 3 over 2.
Root
Root
3.
3 over 2, ma'am.
So meaning that the answer will be root 3 over 2, because according to our diagram, sine here is what? Is negative.
Which is going to be negative root 3 over 2.
Yes. Are we all together?
Yes, ma'am.
Yes.
Thank you. So discharge, and then we go back. And let's see the answer. Let's see. Ooh, we are moving. Ooh, this is so good. Since the value of sine is negative in the you see, when you understand your work, the movement is smooth, very smooth. Look at this. Coterminals. This is coterminal of this one. Hey, the English. Why was it coterminal? Because we kept on subtracting the 360s. Do you remember that's what we did last week?
Yes, ma'am.
We kept on subtracting the 360s until we got here, and we know this one is coterminal with that one. Now with this one, it's easy to find the reference angle because you couldn't go around the circle 16 times to find 16 pi over 6, but it's easier to find 4 pi over 3. So then, well done. Well done, well done. Well done. Let's look at sec negative pi over 4. What is the reference angle, guys? What is the reference angle? What did I say? Remind me, what did I say? What would be the reference angle? And I just said it, I repeat it now. What would be the reference angle? What is the reference angle? For sec. No. Remember, we start with the reference angle, then we go and find sec. What is the reference angle for negative pi over 4?
Pi over 4.
Are we all okay? Why is it pi over 4?
Yeah.
Yes, I'm okay.
Remember, I said if you move from here, if you're moving from here, let's say you started here and then you move around like this, and your angle is here. So meaning that you have moved around like this, theta. Then your theta bar will be whatever angle is this one, minus 2 pi. That's what I said. Because you moved around. But if you didn't move around, you know negative 4 pi. It's just you moving from here to here. As long as you're in this quadrant and you moved from here to here, you know that that's negative pi over 4. Then your reference angle would just be this thing, positive pi over 4. So meaning that your reference here is what? Pi over 4. So this is what? This is sec of negative pi over 4. Now it's sec of the reference number pi over 4. But because we are taking the sec of the reference number pi over 4, according to the Anastasia diagram, what do we know? We know that in the fourth quadrant, cos is negative. Is positive. So meaning that sec will also be positive because cos and sec have a relationship. So this would be positive. So the answer here is what? What is the answer? If you don't know the answer for sec pi over 2, what is the answer for cos pi over 4? Guys, it should be in your mind.
2 over 2. Root 2 over 2.
Root 2 over 2.
Root 2 over 2.
Then sec is 1 over root 2 over 2.
Thank you. Huh? Yes, then what's that? Oh, yes, sorry. So cos is √2/2. We know this is 1 over cos of pi over 2. And we know cos is √2/2. This is 1 over √2/2. So this will be equals to 2 over √2, which is the same as √2.
Yes.
I hope we are all together in this.
Amen.
Today, the session will end very quickly because it's things we know. And the pen wants to delay us. Well done. Well done. Trigonometric identities. Hey. Alala. The trigonometric, you see, you are doing things we did. The trigonometric functions of an angle are related to each other through several important equations called the trigonometric identities. We have already encountered the reciprocal identities. That is what 1 over cos, that's your sec, 1 over sine, that's your cosec, 1 over tan, that's your cot. Those are called what? Reciprocal identities. These identities continue to hold for any angle theta, provided both sides of these equations are defined. Do you remember this table? Don't say you don't remember it. The Pythagorean identities are consequences of this Pythagorean theorem. Pythagorean theorem. We call it Pythagoras theorem. Yay! Yeah. So the fundamental identities, do you remember the reciprocal identities, isn't it? These ones. I'm not going to mention them again. You remember them, right? Guys? Hello?
Yes, ma'am, we do.
Yes,
And then
ma'am.
the Pythagorean identity, sine squared theta plus cos squared theta is equals to 1. Right? And I did show you how to find tan squared theta plus 1 is equal to sec squared theta. Do you remember how we found it? Guys? We said these two identities are derived from this one. You remember how we found it, isn't it? Yes or no? Yes or no, guys? I want to move on with life. No, with the slides.
Yes, ma'am.
No.
From
No.
Yes. From the what?
You mean so from taking that first identity, you could you can divide everything by sine first, or by cos. Okay, I would say divide by cos for the first one.
Okay, let's start by sine first.
Okay,
So
sine first.
it's because you said sine first. Divide by sine squared theta. Now we know sine squared theta divided by sine squared theta, it's 1 plus. Now cos squared theta over sine squared theta is this one here. So meaning that will be what? Cot squared theta, which is equals to 1 over sine squared theta. It's this one. Where is it? This one here. So meaning this will be cosec squared theta. Do you see that, guys?
Yes, ma'am.
So meaning the other one, you have to divide by what? You have to divide by cos now to get this one. Are we all together?
Yes, ma'am.
Thank you. Now they say express sine theta in terms of cos theta. What do you think they mean there? What do you think they mean? Hmm? What do you think they mean?
Must make sine theta the subject of the formula.
Yes. So how can you express it? You can use what?
We use the Pythagorean identity.
Thank you. So meaning that you go and take this one over here. This one over here. That's the only one that had the relationship between sine and cos. So then you say sine squared theta plus cos squared theta is equals to 1. So they wanted in terms of cos, meaning that everything that has only sign will be to the left and everything else to the right. So this is 1 minus cos squared theta, and then they want sine theta and not sine squared theta. So you take the square root both sides. And we know if you take a square root, then here we're left with sine theta is equals to plus or minus square root of 1 minus cos squared theta. Now, because they didn't mention any quadrant, you leave it as plus or minus square root of 1 minus cos theta. Are we all together there?
Yes, ma'am.
Yes, ma'am.
Right, and then let's go to the next one. Next one, what are they saying?
Express tan
In terms of sine theta. So what do you think they mean? Can someone help? What do they think? What do you think they mean? Where can I start then? Let's say, where do I start? You tell me, where do I start?
We start with the first part, express tan theta in terms of sine theta.
Okay, so what is tan theta equals to?
It's
Sine
equals to
theta
Sin
sine
theta
theta over
over
cos
cos
theta.
And
theta.
theta over cos theta.
Thank you. So that's sine theta over cos theta. So because they want us to express in terms of sine theta only, so it means that which one are we changing so that it looks like sine
Cos
theta?
theta. Cos
And
theta.
how are we changing it? How are we changing
Yeah,
it?
we're gonna say 1 minus sine theta. I don't know.
Thank you. So you say 1 sine squared theta. What did I do? Theta plus cos squared theta is equals to 1 because we want cos only. So cos squared theta is equals to 1 minus sine squared theta. Then cos theta is equals to plus or minus the square root of 1 minus sine squared theta. How do we decide on the sign of cos?
It's positive since it's on the
Quadrant.
second quadrant.
So
Sine
the
is
cos,
positive. Cos is negative.
so cos will be what?
Negative since it's on the second quadrant.
So meaning that this will be equals to negative square root of 1 minus cos, sine. Okay, so let's say here, therefore cos of theta will be equals to negative square root of 1 minus sine squared theta. So then this will be equals to sine of theta over square root of 1 minus sine squared theta. Negative, sorry. Are we all together there?
Yes, ma'am.
Okay, let's see
Yes,
if we're
ma'am.
correct
So
or
my
not. Yes.
ma'am, so here, can I ask before you pass? You use the identity even though you saw that cos theta has no squared. So you just use the identity straight on cos.
You're saying I use the identity even though I know
Yes.
cos doesn't have a square.
Yes.
It's because I went to the identity. I know that because they want tan to be with signs only, ne? So I knew that I have to use the identity cos squared plus sine squared theta plus cos squared theta is equals to 1, so that I can have the sine but remove the cos. So from there, I then solve for cos only. Do you see that? I only have cos only. That cos only is the one that I went and substituted here.
Okay, ma'am. Thank you. I get it now.
Okay, sharp. Okay, let's see if we are right. The first one, we are right. They say if theta is in the first or second quadrant, then sine is positive, then it will be like this. Whereas now they're showing the quadrant. Remember, we got sine of theta is equals to plus or minus square root of 1 minus cos of theta. So here they are saying that in the first and the second quadrant, sign is positive. It means that it will only be the positive one like this, which is this one over here. And then, oh, sorry, plus or minus. And then where else in the third and the fourth quadrant, sign is negative. So it means it will just be that one there. Are we all together?
Yes,
Yes.
ma'am.
Yes, ma'am.
And then since, okay, so here they say since tan theta is equal to sine theta over cos theta, we need to write cos theta in terms of sine theta. That's what we did here. So then they say since cos theta is negative in the second quadrant, the negative sign applies here. Do you see? So that's what we got there. This is our answer. Are we all together?
Yes, ma'am.
Now let's look at areas of a triangle. They say the area of a triangle is equals to half base times height, right? Now they say if we know two sides and an included angle of a triangle, then we can find the height using a trigonometric function. And from this, we can find the area. Does it make sense what they are saying? Guys?
Yes, ma'am.
What is an included angle? Let's start there before I continue. What is an included angle?
It's an angle that you are given, like on a triangle, whether it's we have two sides and one angle. That one angle is gonna call it an included angle, I think.
Like this. Sorry. Like this. Two sides and an angle.
I think
Yes,
they have to
ma'am.
be included in between those lines, like on the corner.
Thank you. So this is the included angle. Does it make sense, guys?
Yes.
Yes, because it
So-
has to be
Yes,
between the
ma'am.
sides
Yes,
that
ma'am.
are given.
Yes. So if this is the side and this is the side, you need to be between the two sides. If this is the side and this is the side, between the two sides, then that's called an included angle in maths. So if they say angle only, then it's fine. They talk about any angle. You can put it here, you can put it here, whatever. But immediately when they say included two sides and included angle, then you need to include the angle between the sides. So they are saying that if we have a triangle like this, do you see that now there's an A here and there's a B here and there's an angle. So they have this side and the included angle. That's what they were talking about. Included angle of the triangle. Then they say that we can go and calculate the area of that function there. Are we all together, guys? Yes or no?
Yes, ma'am.
Yes, ma'am.
So they say, okay, fine. We have this triangle like this, right? So we have A here, we have B here, and we have theta here. Now, you know when we have a triangle like this, for us to calculate the height of a triangle, you go and check the highest point on the side must be perpendicular to the base. You know that, right? Remember when you were looking at when calculating the areas of rhombus, of diamonds and whatsoever, even a triangle. Do you remember that one? Yes or no?
No, ma'am.
So meaning that you can't go and draw a line like this to form a half base, like this, and form a half base, or a line that starts from here and form a half base. You have to go and check where the line starts from the point to where would the line start so that it can be perpendicular to the base. The line cannot start here because it won't be perpendicular to the base. The line won't start here because it won't be perpendicular to the base, won't be perpendicular. Do you see the only time the line becomes perpendicular is when you draw from here and go down straight. Ooh. The only time it will be from here and go down straight like this.
Yes, ma'am, because that's when it forms the right angle.
Thank you. That's when it forms the right angle. So it's perpendicular to the base. Do you see that? Now,
Yes, ma'am.
because we know
Yes, ma'am.
because we know A and B, how can we find this one? Let's call it the height H. How can we find it? I don't know why it's, how can we find it H? Because we have the angle and the sides. How can we find it? Let's not use Pythagoras because it's long. So say what? We want to find H. So H will be what, guys? Use your trick, guys. We've been doing this. Last time we found the height of a tree using our trigonometric ratios. Now we are forgetting our trigonometric ratios.
Ma'am,
Yes.
can't you use cos rule? Whatever. Yeah, I think it's the cos rule or cos.
We can
Wait,
use
ma'am.
cos.
Use sine.
Ma'am,
Let's
Theta.
use sine instead.
aren't we going to
Sine.
use
Oh,
sine
yes.
theta, ma'am?
So you say sine theta is equals to what?
It's going to be opposite over hypotenuse, right? Which will give us A over H.
So it will be what?
Sine theta is equals to
Yes.
H over A.
H over A. So H will be equals to what? A sine theta. Do you
A
see
sine
that?
theta. Yes, ma'am.
Because you can't use cos. If you use cos, cos will be what? Cos will be B over A. Do you see that? And there's no H here. So now the area, it says it's equals to half base times height. Right? Now we know that, can you please mute there? We know that our base, what is our base, guys? Our base is B, isn't it? The base of a triangle.
Yes.
What is the height now? The height is A sine theta. So it's A sine of theta. So meaning that that can be given 1 over 2 AB sine theta. Meaning that if you have a triangle with two sides and an included angle, you can use this formula to calculate the area of that triangle. Are we all together?
Yes, ma'am.
Yes, ma'am.
So that's the formula there. Now they're saying that if the angle is not acute, then what happens? So if the angle is not acute, you know that, okay, fine. This is the triangle that you're forming. Do you see how the triangle was? It was like this. I can't draw triangles, right? It was like this. And this is the angle that you were focusing on, right? Guys, do you see that? So this is AB,
Yes,
right? And now, because you can't draw any line that will be perpendicular such that it's perpendicular to the base on this particular tree. So meaning that you can, do you understand what do I mean? But you can't draw any line that is perpendicular to this triangle from the base. Guys?
Yes, I can see.
Yes, ma'am.
So meaning that the only time you can construct a height is when you draw a line outside and say, and make sure it's perpendicular to the base. So you assume as if you are extending the base. And now this becomes your height. Now, because your angle is this one, and it's not an acute angle, you know the property for you to get this angle, you know the reference angle, isn't it? For you to get this angle, you say what? Theta plus theta bar is equals to 180 because you're saying angles on straight line. Do you remember that one?
Yes, ma'am.
Then it
Yes.
means
Yes.
for you to find theta here, for you, so meaning that you'll go and find theta bar to actually find theta. So then this would say theta bar is equals to 180 degrees minus
theta.
theta. Are you all together? And we
Yes,
know
Yes,
that,
ma'am.
Yes, ma'am.
so H is equals to, so we know that sine of 180 degrees minus theta, if we go to the Cartesian plane, on the Anastasia diagram, you know that 180 minus theta, it's somewhere here, isn't it?
Yes,
Yes, ma'am.
ma'am.
So it means that sine will be what? Will be positive. So this is the same as sine of theta. So they are saying that you can still use this formula even if your angle is acute or not. Even if your angle is an acute angle, meaning angle less than 45 and 90 degrees, or an angle which is an acute angle which is less than 180 degrees, you can still use this formula. So they're saying this is because the reference angle of theta is the angle of 180 degrees minus theta. Thus, in this case, also the area of the triangle will be like this. Are we all together there, yes or no?
Yes, ma'am.
Yes.
So now they're saying the area of a triangle with sides of A and B with an included angle is this one over here. Doesn't change. So now find the area of the triangle. So area is equals to half AB sine theta. So this is equals to what, guys? What's the answer? Let's substitute.
Ma'am, isn't it going to be half multiplied by A is going to be the value of 10.
Okay, we can make it
No,
10.
no, no, no. Yeah. Okay. Multiply by 3 sine 120.
Okay, so normally they like putting, you see this A, this big A, ne? And then opposite this big A, they'll make a small a. You see this big B, opposite this big B, they'll make it a small b, this C and whatsoever. But you don't have to do that. But now, because we are looking at, I'm just showing you how they will like write their triangles. But because they didn't write anything, so you can say this is A, this is B, or you can say this is B, this is A. Times sine what?
Sine 120.
What is sine 120 degrees without using a calculator? Without using a calculator. Yeah, I'll calculate this. 10 plus 30, that's 10 plus 3, that's 30, so this is 15. Can someone tell me sine 120 degrees without using a calculator?
Is root 3 over 2.
Now look at this. We're looking at degrees, so talk degrees. Talk degrees. You can't say root 3 over 2 first. Talk degrees.
Ma'am,
Yes.
All right. It's a,
ma'am,
Yes, I'm listening.
okay. What if we break down the 120 into sine into 120 sine into 180 minus 120, which will give us sine into 60.
We didn't break it down. What did we do?
it's an sine of a 180 minus 60.
Yes, that's what he said. But
To find
we
the
didn't-
reference angle.
Thank you. We found the reference angle. We didn't break it down. We're finding the reference angle. So we're saying sine of 180 degrees minus 120 degrees. So this is equals to, so let me write it here. This is equals to 15 sine of what? Sine of 60 degrees. And we know sine of 60 degrees is what? Sine 60 or sine pi over 3 is what, guys? I see
Root-
some forget.
Root 3 over 2.
Thank you. 3 over 2. So this is equals to I think we can leave it like this. Root 3 over 2. So we can just say 15 root 3 over 2 because I don't want you to use calculators. So we can leave it like that. What matters to me is you are able to apply and understand the work, not the final answer. If you notice, that's why I'm saying because we're not using a calculator, we can leave it like that. You can always put that in a calculator. You can even ask a grade 1 learner to put that in a calculator. But if you understand the work, that's what matters to me. Okay? Did we all understand that part, guys, before I discharge?
Yes, ma'am.
Yes.
Okay. Let's see if what we did is correct. Yes. So they use the calculator to get this part. In the exam, I'll only end here. Are we all happy, guys?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So we finished this
What?
slide. Any questions on this particular work? And then I switch off, we go to the next slide. Before I don't save the work. Any question?
What I want to ask, ma'am, I don't know if you can hear my question, is that with the triangle of the acute angle, the acute triangle, you have to draw a line from the head to make it perpendicular, and then you'll use the head of it. Then, so we are using for area, we are using the same formula. I don't know. We are using the formula, the same formula with also the obtuse. Is it the obtuse? Also the obtuse triangle.
Yes.
Yeah. So I'm like a little bit confused. With,
Okay.
why is
So
it
remember,
the same one?
why is it the same one? The same one comes in the fact that the acute triangle is somewhere here, right? It's an angle that is less than 90 degrees. Do we agree, right?
Yes.
Now the obtuse angle is somewhere here, meaning that you move from here to here. It's an angle that is less than 180 degrees. Do we agree that?
Yes, ma'am.
So meaning that this one, we know it will be sine of theta, isn't it?
Yes.
Now, because we are using the reference angle, we know that according to the Anastasia diagram, we know that sine, acute angle will be in the third quadrant and sine will be positive. Are we all together?
Yes, ma'am.
Now we go and find the angle, the reference angle bar. In this case, the reference angle will be 180 minus this theta here. So that's sine of 180 degrees minus theta. Do you see that?
Yes, ma'am.
And we know that what's this? The angle of the the answer of the reference angle is exactly the same as the answer of the angle. The only difference is the sign. It means that because we are here and we know sine is positive, so meaning this will be sine of theta, which is equal to sine of theta. So this one and this one are the same. That's why it leads us to come at this point and have the same formula for whether it's an obtuse or whether it's a acute triangle.
Yes, ma'am. Thank you.
Makes sense now. You're welcome. Okay, I'm discharging, guys.
Ma'am, I still have a question though.
What's the question?
While you're on that one, so why is it our base will still remain the same?
Why is it our base?
Yes.
Yeah.
Because we're gonna extend that theta, that reference angle, but you're still using the same base.
It will always be the same base because remember the base is in the standard position. Your angle is in the standard position. Does it make sense? Let me draw. Okay. All your triangles will start here. All your triangles will start here. Do you see that on the yellow part?
Yes. Yes, ma'am.
That's where that's your base of the triangle, isn't it? Let me choose this color. This is the base of your triangle. Are we all together?
Yes, ma'am. Yes,
Now,
ma'am.
if I happen to
Ma'am,
form a triangle,
ma'am,
yes.
draw that triangle for 120 that we had first, like before. Go up. So maybe I can ask my question. Yes, you see there. Draw the height going down on C going down.
So, meaning that you can't draw any height here such that it's perpendicular. The maximum point such that it's perpendicular here, right? So you can't draw a maximum point. In this case, our maximum point is here. You can be drawing perpendicular lines, but then you can't say from here, like it logically, this cannot be the height of a triangle. Do you agree? Even if it's perpendicular. Do you see that?
Yeah.
This one cannot be.
Yes, ma'am.
And then, meaning that so the maximum point of a triangle is this one here, right? And if you draw it inside here, it will never form a perpendicular. So even if you draw a line straight from that height to here, it will never form a perpendicular line. So if you remember when you were looking at, I think it was Euclidean in grade 10, and you were looking at your rhombus, all those funny shapes, the parallelograms.
Yeah.
Do you see that? So what they did was you go and extend from outside. You go to the maximum point here and go and draw up to down, 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 and then you extend your base like this. Do you see that?
Yes, ma'am.
And then this becomes your height. Now, because this becomes your height, now you know that this angle here, let's call it theta. Theta will be equals to 180 degrees minus 120 degrees, because these are angles on a straight line. And this gives you what? This gives you 30 degrees. Do you see that?
Yes, ma'am.
And we know
It's
that.
60, ma'am.
Sorry. Yes, thank you. So this gives us what? 60 degrees. And we know that this, as we have learned, that 180 degrees minus theta will always be sine of what? Of theta degrees. This is true that sine of 120 degrees will be equals to sine of 60 degrees. Because we understand this relationship from our Cartesian plane.
Oh, now I see.
That is why in grade 10, 11, and 12, you were doing something you didn't understand, but you were doing it and you passed it. Remember, when we were doing, let's say you were given a Cartesian plane like this. Do you remember that one? And they say maybe cos theta is equals to 5/4, and they want you to sine 180 degrees minus theta, and you didn't know that sine 180 degrees minus theta is the same as sine theta. Do you remember that one?
Yes.
And then they give you, for example, something like this. Okay, let's start in the first quadrant. We knew in the first quadrant they'll give us something like this, and then they say this is the point, and maybe let's say this is the 4 and the 5. This is 4, this is 5, and let's say this is 3, something like that, right? We're just making an example. You remember you were drawing a dotted line and extending it like this and forming a 90 degrees, and then you go and do the theta there, and then you start solving your problems that they ask you. Do you remember that one?
Mm-hmm.
And then there was another question where this is an acute angle, and then you obtained the obtuse angle. They say now, okay, let's say we have now something like this. An angle like this. Do you remember that angle was also an obtuse angle? It was like this, guys. It was an obtuse angle, but you can't form a 90 degrees from here. Do you remember that theta? What you did, you went and draw a dotted line and form the 90 degrees and focus on the inner theta and solve the problem. Why? It's because of that relationship that we talked about that says if you say sine of 180 degrees minus theta is the same as sine theta.
But you're still using the 3 centimeter, ma'am, even though we've constructed C there, but you're still using the same measurement of the skewed line. Whereas also in the acute angle, we were using the measurement of the straight line that you have constructed. So I think that's a little bit of, that's that little bit of confusion, but I get it, ma'am.
Take me back. You're saying we're using what?
Like with the obtuse angle, if you construct it down there, you construct the line down there so that you can use the reference of 60 degrees, but we are still required to use the measurement of the skewed line, not the one that we have constructed, the straight one. So it's like we want to understand.
Yeah, it's still the same height. It's still the same, it's just that they slanted it.
Oh,
remember when, yes, it's still the same line. Nothing has changed. Remember when we were looking at the tree, we used the shadow to find the height of a tree.
Yeah.
Do you remember that?
Yes, yes.
We used the shadow to find the height of the tree. Even if we used the shadow, it didn't change our tree.
Yeah.
Our tree remained the same.
Okay, man.
Do you see that? Because we had the sun, the tree, and then we had the shade of the tree. So the shade of the tree helped us. Only helped us, meaning we extended the. We extended because we know the angle there. We extended here to help us find the height of this thing.
Mm-hmm.
Same thing is here. You are extending here. You're not doing anything to the side. You're just extending. It will help you to find the height of the tree.
I understand them now. Math is nice.
Thank you. Okay, I'm taking no more questions. So I'm stopping the recording. And then we go to the second session. The reason why I want to do two sessions